Hello everyone, welcome back. As I have promised in the previous video, today we will continue chapter 8, and the first thing I will do is to explain the reason why we choose NPV over IRR for our investing strategies. So NPV and IRR will generally give the same decision, except for two cases. First, non-conventional cash flows. Non-conventional cash flows means cash flow sign changes more than once. Second case is that mutually exclusive projects. Mutually exclusive projects means that if one project happens, the other will not. Take an example in real life. If war exists, so peace cannot exist. So one thing takes place, the other won't. In other words, initial investment are substantially different, timing of cash flows is substantially different, and it will not reliably rank the project. So they cannot rank the projects. So non-conventional cash flow change sign more than once. The most common case is that the initial cost will be negative because you take the money out of your own pocket. There will be a stream of positive cash flow in the future. However, at the end of the project, there's a negative cash flow. So for example, nuclear power plant or strip mine. Let's do this example together to understand why can't we use IRR for non-conventional cash flows. Let's read through it together. Suppose an investment will cost $90,000 initially and will generate the following cash flows. Year 1, 132,000. Year 2, 100,000. Year 3, minus 150,000. The required return is 15%. So, should we accept or reject the project? Let's first draw a timeline. So our timeline will be looking like this. This is year 0, year 1, year 2, and year number 3. The cash flow in year 0 is minus 90,000 because we invested 90,000 USD. So CF0 is equal to minus 90,000 USD. In the following years, we have 132,000, 100,000, and in the last year of the project, it's a negative number, 150K. So this is an example of an unconventional cash flow. Normally, a cash flow should look like this. For example, 90,000, 100,000, 110,000, and 300,000. So a normal cash flow will be looking like this. I'm sorry, year 0 is minus 90,000. So they only have one negative number. But for the rest of the period, they're all positive number. This one is the conventional cash flow, the traditional cash flow that we are used to, that we always talk about since the first video of the course. But in this example, the cash flow changed the sign more than one time. In year 0, it was minus 90,000. In year 1, year 2, are positive numbers, 132,000 and 100,000, respectively. But in the last year project, it becomes a negative number. It's 150,000 minus 150,000 USD. Therefore, we call this one an unconventional cash flow. Now, let's do this exercise together by using the IRR method. So as we all know that IRR is the rate that makes NPV equal to 0. And the formula is 0 equal to the total sum of all cash flow to the power divided by 1 plus IRR CFT, and n start from 0. This one is to the power of t. And applying the formula into this exercise, we can see that 0 should be equal to minus 90,000 plus 132,000 divided by 1 plus IRR plus 100,000 divided by 1 plus IRR to the power of 2 and plus minus 150,000 here, minus 150,000 in year 3 divided by 1 plus IRR to the power of 3. Let's find out the answer. Using any type of calculators or doing hand calculation, I got two different answers. So IRR could be either 10.11% or 42.66%. And this can happen because we have more than one sign, more than one time where the sign change. That's why when I use the calculator, it gave me two different answers. So if the answer is 10.11%, do we accept or reject the project? Here, the IRR is smaller than 15%, which is the required return, DR. So therefore, we will reject. If the IRR is equal to 42.66%, this indicates that it's bigger than 15%, bigger than the required return. So we should accept the project. So now let's answer the question, should we accept or reject the project? How do we know? The answer is we cannot know because it gives a two different answers. So there is no way for us to decide, should we accept or reject the project? Therefore, as I have mentioned before, using IRR method is not the optimal strategy because sometimes it gives us two different answers. For example, here, the non-conventional cash flow case. Now, let's try to do this exercise by using the NPV method. Let's see if the NPV method gives us different answer or not. We are now using the BI calculator in order to find the NPV of this project. First step, we activate the CF function. CF0 is minus 90,000. Enter, go down. CO1 is 132,000. Enter, go down. FO1 is 1, of course. Enter, go down. CO2 is 100,000. Enter, go down. F02 is 1. Enter, go down. CO3 is 150,000 minus 150,000. Enter, go down, and F03 is also 1. So we press enter. And now we press NPV. We input the required return, which is 15%. But just a reminder, we don't use the percent sign, the percentage sign. We only use the number 15. So 15, enter. Now we press going down. Here we press CPT. And the answer is 1,769.5. So the NPV of the project is equal to 1,769.5. So what kind of conclusion can we make from this number? So because the NPV is greater than 0, therefore, the decision rule, anytime the NPV is bigger than 0, we should accept the project. Therefore, in this case, because 1,769.5 is bigger than 0, so we should accept the project using the NPV method. However, just a reminder, if we use the IRR method, it gives us two different answers. We won't know whether should we accept or should we reject it. But NPV will tell us immediately that we should accept it. Therefore, in this kind of scenario where we have a non-conventional cash flows, we should use NPV as our primary investing strategies. However, we can still use IRR by fixing it, by adjusting it. In the next slide, I will introduce you guys 3 ways to fix the IRR method in order to make it as powerful as the NPV method. So as to solve the problems with IRR, we have three methods. The first method is discounting approach. We discount the future outflows to present and add it to CF0. The second method is reinvestment approach. We compound all the CFs except the first one forward to the end. And the third is combination approach. We discount outflow to present and compound inflows to the end. Now, let's first try to do an example with the first method, the discounting approach. So there are three steps. The first step is to discount the future outflows to present and add to CF0. The second step is zero out negative cash flow which have been added to CF0. And step 3 is compute IRR normally. What do I mean by these steps? Let's try to do the example together. So for example, we have a project. We have the required return of 20%. Then we know that in the first year, in the current year, which is year 0, we invest $60. So the CF0 is minus 60. Then CF1 is $155. And at the end of the project, year number 2, we have the CF2 of minus $100. So it is clearly an unconventional cash flow. So if we use IRR here, it may create some kind of mistake, some kind of bias. And therefore it's suggested that we should change the method. We should use NPV instead. But because there are ways to adjust it, therefore we're gonna use the discounting approach. Let's get our hand dirty right now. So step 1, we discount the future cash flow. Discount future cash flow, only negative cash flow to present and add to CF0. So which one have negative cash flow in the future? So it's year number 2 because we have minus 100. So we need to discount it to year 0. And using the discounted cash flow formula, minus 100 divided by 1 plus DR, 20%, to the power of 2. And we will get minus 65.444. So this number means that at the current time, minus $100 in year 0 will be worth minus 69.444 at the current time. So minus $100 in the future will be worth this much in today date, year 0. So because we already discounted to the current time, therefore we can take this number and add it up with minus 60, which is our step 2, zero out negative cash flow which have been added to CF0. So therefore our new timeline will be looking like this: year 0, year 1, and year 2. Since we already discounted year 2 and we add it back to year 0, so the cash flow in year 2 will be equal to 0 instead of minus 100. Year 1 will still be 155 because we didn't do anything with the cash flow in year 1 because it is a positive number. And for year 0, since we take minus 60 plus minus 69.444, we will get the cash flow 0 equal to minus 129.444. Next step, we calculate the IRR using the IRR formula. So year 0 is equal to CF0, which is 129.444 plus 155 divided by 1 plus IRR to the power of 1. And the answer we get from the calculation is IRR equal to 19.74%. Since the IRR is smaller than 20%, therefore we should reject the project. So by fixing the IRR method with the discounting approach, we won't get two different answers anymore. And now we can answer whether should we accept or should we reject the project. Here in this case, we reject because IRR is smaller than R. Popping up on the screen right now is the second method. We call it reinvestment approach. So step 1 is to compile all the cash flow except CF0 to the end of the project's life. The step 2 is to zero out all the cash flows which have been added to the last year of the project's life. And step 3 is to compute the IRR normally. Let's do the example together. So suppose that we have a project, a 2 years project. The required return is 20%. The CF0 is minus 60, which is the money we invest. In the first year, it generates $155. And in the second year, which is also the end of the project, it generates minus $100. First step, we compound all the cash flow except CF0. So we don't compound this one. We don't compound this one. We only compound CF1 to the end of the project's life, which is year 2. And what do I mean by compound all the cash flow? So we need to compound it in order to zero out. Zero out means make it zero. So our goal is to make the cash flow in year 1 become zero by adding the future value of CF1 to CF2. Is a reverse version of the discounting approach. To compound it, because we know that the required return is 20%. So CF1, which is the amount money generated in year 1, 155 times 1 plus 20%. And this will be equal to 186. So $155 in year 1 will be worth $186 in year 2 after 1 year. So in the future, 1 year future, this amount money will be worth $186, knowing that the return is 20%. Next step, we zero out all the cash flow, which have been added to the last year project's life. So therefore, our new timeline will be looking like this. Year 0 is still minus 60. Year 1, because we already compounded and we added to the last year, so in year 1, the CF will be 0. And year 2, the CF will be minus 100 plus 186, which is the future value of the cash flow in year 1. And this one is equal to 86. Again, we have solved the problem of the unconventional cash flow. Because 0 is a positive number and 86 is also the positive number, so the cash flow, the adjusted cash flow we have, only changes the sign once. So we can use the IRR method now to compute and decide whether should we accept or reject the project. Applying the formula, we have 0 equal to minus 60 plus 0 divided by 1 plus IRR to the power of 1. Because 0 is the new cash flow in year 1, the adjusted cash flow, plus 86 divided by 1 plus IRR squared. Using any calculation or doing hand calculation, I got the answer of IRR equal to 19.72%. Again, this number is smaller than 20%, which is our required return here. And because it is smaller than 20%, therefore again, we reject the project. And the last method we are talking about is the combination approach. Just like the name, it's a combination of both discounting approach and the reinvestment approach. So step 1 is to discount all the outflows. For example, in this exercise, all the outflow except CF0. And the only outflow we can see is at the end of the period, which is minus 100. We discount it to present and add it to CF0. Then we compile all the cash inflow to the end of the project's life. All the cash inflow. And the only cash inflow I can see is 155 in year 1. So we will compound it and add it to year 2. Finally, we compute IRR normally. So how are we gonna do it? Step 1, minus 100 divided by 1 plus 20% to the power of 2, and this will be equal to minus 69.444. Next step, we will add it up to CF0, so our new adjusted CF0 will be equal to minus 69.444 plus minus 60, and this one will be equal to minus 129.444. Second step, we compile all the cash inflow to end of project's life. So we can only see 155. So 155 times 1 plus 20%, we compound it. This will be equal to 186. Notice that we don't need to add it to the end of the project, but we use this number straight, and our new CF2 will be equal to 186. What is the reason? Because we have already discounted the cash flow in year 2, the negative number in year 2, to year 0, which is the current year. So this number, minus 100, is no longer there. So when we use the combination approach, and in this case, the reinvestment approach, inside the combination approach, we only need to use the number that we compound the cash inflow to the end of the project's life. In this case, it will be $186. And step 3 is to compute the IR normally. Let's draw a timeline together again. Our new timeline will be looking like this. Year 0, our new cash flow is 129.444 minus 29 minus 129.444. In year 1, it's going to be 0 because there's nothing in year 1. And in year 2, it will be 186. Next step, we just need to apply the IRR formula. So 0 equal to minus 129.444 plus 0 divided by 1 plus IRR to the power of 1 plus 186 divided by 1 plus IRR to the power of 2. The final answer we get is IRR equal to 19.87%. Again, because it's smaller than the R, which is equal to 20%. So we should reject the project. So in conclusion, after all the approaches that I have taught you guys, we can all see that they are used to solve the only problem, the unconventional cash flow. It helped to make unconventional cash flow become conventional. And so in order for us to use the IR method as an investing strategies. And the last concept I want to introduce you guys in this video is the profitability index. So profitability index is only used for conventional cash flow projects. So in case we have a non-conventional cash flow, always remember to adjust it. The formula is the total sum of all the future cash flow discounted to current time divided by the absolute value of the initial investment. In other words, this one is equal to benefit divided by cost. It's a cost-benefit analysis. Why do we use the absolute value of the initial investment? Because the CF0 is a negative number. So if we want to calculate the profitability index, we need to use the absolute value to make it a positive number. Therefore, we can calculate the profitability index. Here in this example, we have CF0 equal to minus 10. We invest $10. In the first year, it generates $10, and in the second year, it generates $20. And we know that the required return is equal to 10%. So applying the formula, PI, profitability index, will be equal to CF0 minus 10 plus 10 divided by 1 plus 10% plus 20 divided by 1 plus 10% squared. Then we divide with the absolute value of C of 0, which is minus 10. And this will be equal to 10, of course. And then this calculation will be equal to 25.62 divided by 10. Finally, we get the answer of 2.562. So is this a good profitability index? Well, yes, it is, because the rule of thumb is that anytime the PI is greater than 1, it's going to be a good profitability index. Since the answer we got is 2.562 greater than 1, therefore the project that we are talking about right here is a good project, and maybe we should accept it. This is also the end of the video. Please rewatch it carefully. And finally, thank you guys for watching.